All right, so we are back, and we are going to the next presentation. Sorry. So next presentation. So it's going to be predictive performance modeling using machine learning algorithms. So it's going to be presented by Hemalatha and with his colleague Madhu will be also connected, so there will be a demo part as well. I think it's a smooth transition between the presentation done by Ruben with observability, the fact that you need to collect data in a smart way, collect the right sampling, and to utilize to make decisions. And I think now with the new algorithm that available, especially in machine learning space, it helps you to make decisions, to detect potential problems, where you should potentially do the optimizations, figure out how you're going to scale depending on what you have seen in production and the results that you have in performance. So I think it's a great topic, pretty useful. I think it's the beginning of combining machine learning and testing. I think there is a much more relevant things that we can enter then, and I think it's going to be a super interesting presentation. So those is I've never heard about Hemalatha Murugesan. I mean, she's has over more than 22 years of experience. She is working for Infosys, and she's basically managing the performance practice. So she is, I would say, an expert and knows a lot of things on the performance testing space, using the safety virtualization, cloud testing. So she's been dealing with a lot of big names of the industry. So most of the 500 Fortune 500 customers. She's been co-authoring some books, speaking in a lot of different international conferences. So it's really an honor and a pleasure to have Emma with us today for this virtual pack. So thanks, Emma, to be part of this pack. So I will unmute. Where is you? So for you, here it is. So it's really an honor to have you on board. So Emma, you can start sharing the screen. So and Madhu, I put you on mute as well. So I don't know if you want to mute Madhu first and Emma, let Emma. So I'll leave you share the screen, and if there is anything, I will unmute myself to tell you if there's any connectivity issue or if you do the demo and you're not seeing your screen, I'll let you know if it is a problem.
Are you able to see the screen?
Not yet. I see the webcam perfectly, but I don't see your screen yet.
Are you able to see it?
Not yet. No.
I put it on share.
I don't see personally. I don't see anything. No, so Stefan is confirming that we don't see anything yet. Here it is. I can see the screen now. All right, okay. Perfect.
I will put it on a slideshow so that you'll get to see. Is it visible?
Yeah. It's visible, but we are currently. I'm seeing the two screens. I see the presenter mode and the slides on the same. So I think it seems that you're using two screens. I don't know if you have the options to select on.
Okay, let me do one thing. I'm going to show it like this. Is that okay?
Okay, perfect.
Fair enough. Just to avoid time. So before I get started, I just want to make sure that there is no audio problem like we faced in the previous speaker, and it was very unfortunate. Ruben has been an expert, very good speaker, but it was quite unfortunate we couldn't hear him. So just wanted to get a double check that there is no audio problems.
No, everything is fine. I can hear you very well.
Sure. So just Madhu, are you unmuted and you're able to hear? You're able to speak?
Yeah, I'm able to speak. I hope there are no issues from my end too with respect to the audio.
Sure. I would, before I get started, I would like to introduce Madhu, who is part of my team. He's a senior tech arc, working in the part of the reg services, that is reliability engineering and assurance services. Comes with almost close to 18 plus years of experience, and very well versed in different dimensions of the performance engineering is what I would say. So today, the topic that we're going to cover is predictive performance modeling using machine learning algorithms. First of all, Henrik and Neotys, I would like to thank for giving us this opportunity, and good day to all. It gives me an immense pleasure to be part of this performance advisory on the virtual conference that is happening across the geographies of the world. And thanks to all the folks who have joined us on this WebEx, on this online conference. Very interesting for us to share through this medium. Today, this particular thing, machine language, predictive performance modeling using machine language, or ML as it's shortly called. Earlier, we used to hear ML means maternity leave, and that's how we used to hear talking. But today, ML means machine learning, so completely different, connotation and abbreviation that we are into. And we also know that if any organization or a project is not saying that I'm dabbling with machine learning or an AI, then it's kind of considered outdated in the technology adoption roadmap. So before I get on to the core part of it, I just thought I'll begin with a story which is very relevant, in the current context. So, I hope people are able to see. I've just moved on to the next slide. This is a long ago, very brief story though, but very important and relevant, as I mentioned. Long ago, a very renowned, enlightened sage from Himalayas was, walking across the country and happened to visit a village. As usual, the sage was staying under a banyan tree meditating. So the village folks used to come to the sage and seek his blessings and, kind of pour out all their woes and ask them how and seek remedies, which is typical in India that we already know about it. So this one day, it so happened that, when these villagers came to his, hermit, it so happened that he was preparing his meal. And he lit the fire and placed the pot with the water to boil. And then when it started to boil, the sage slowly pulled out a stone from his bag and dropped it into the boiling pot. The villagers were actually shocked. How could he prepare with this stone putting it into this boiling pot? And the sage smilingly replied that the stone is a magical stone and is capable of preparing any dish one wanted. The curiosity amongst the villagers only increased and asked how could it taste. The sage once again said, smilingly, very tasteful, depending on what you want to. He took a small spoon of water from the boiling pot to taste and stated, if you can add few vegetables and some spices, a little bit of salt, I think it would taste much better. I would be more than happy to share with you folks. So one of the villager amongst the crowd just ran and brought these, vegetables and spices and whatnot that the sage requested for. The sage just took them, cut them, and put it into the pot, and it started boiling. And he started smiling. After some time, he said, I think we need to thicken this. Can we get some rice? And out ran another villager, got the rice, and kind of put it into, and the sage put it back into the boiling pot. After some time, when everything was done, the whole meal was cooked and all those things, he said it's done, and he pulled the stone out and cleaned it and put it back in his bag. The villagers were very happy as well as puzzled to see the magic stone having cooked the meal that they desired for. And having tasted it, they just went back, talking a lot about the magic stone and how the sage is, very enlightened and all those kind of things. Now, one might wonder how is this story relevant to our topic that we're going to cover, which is on predictive performance modeling using machine language. Very, very simple. The success or the failure of the modeling using machine language or AI depends on the volume of data sets, like the way we provided on the vegetables, the spices, and other ingredients put into the boiling pot. Now, whenever we go and talk to any project teams or anything, everybody wants to embrace, this particular thing, machine language. But when we ask for the data, boom, we don't get response. We get all kinds of excuses, all kinds of constraints, but yet they want the best algorithm that needs to come across. So that is where the challenge we are seeing in most of the projects that we are working on. And we do have a demo shortly later in the in the next couple of minutes. We will show you a demo as well that we actually piloted it in one of an account that we actually worked on. So coming back, if you're able to provide the right data sets, the algorithms that we can generate either by testing or training the data set, we'll get a meaningful algorithm that we can generate for better results. And for those of you who know, China is conducting a lot of testing with live or production-like data to generate the right algorithms. One of the things that Henrik asked before we get onto this, there was a question on that. For example, for a driverless car testing, China pretty much created its own city with all the traffic signals and all that needs required, complete simulation with the real city to come to a how a driverless car needs to go on a road. They were able to generate good algorithms around it. Similarly, if you see for facial recognition, if you notice, multiple cameras are fitted inside the public bus or public transport and in few of the public places so that they are able to capture the images under different dimensions and at different facial expressions and stuff like that, so that you'll be able to come up with a better facial recognition algorithms. So whether coming to your thing, whether do we really need a sample or this one, then again, it all boils down to the vegetable, the story that we had. The better one that you provide, data sets, the better real-like kind of thing, you get a better algorithm, or more dependable, and accurate results that we can predict. Moving on to the next slide, why do you think there is a need for predictive modeling? Okay. Today, we are living in a very, very fast, rapid, environment surrounding DevOps, agile, and faster to roll out into production, where speed and accuracy is the key. Predictive modeling actually gives the relevant stakeholders and the decision makers an insight into the system behavior from the non-functional point of view. It gives you a better predictability on the system's responsiveness and its behavior under various conditions and environment. It also helps the utilization of the environment, both in terms of its effectiveness and its efficiency. Predictive modeling also provides an insight on the scalability, the threshold of the system under various conditions, and the decisions the businessman can take on it. But it again boils down to on the volume and the kind of data sets that is being given. I now hand over to Madhu, who is going to walk us through a few next slides and the demo as well. Over to you, Madhu.
Thanks, Emma, and thank you, Henrik. And as it's a great event, and I'm really happy to be part of this Performance Advisory Council 2019, hosted by Neotys. So just to further continue where Emma has left, I'll be sharing my screen. I hope you're able to see the screen.
Not yet.
Yeah. Okay, so to continue where Emma has handed over to, are you able to see my screen, Henrik?
No, at the moment I don't see.
Okay, just give me a minute.
I think if you put it on slideshow, you have a problem. Do not put it on slideshow.
Okay. So are you able to see it now?
No.
Okay.
No. Still.
Not yet?
Okay, let me share then. Continue sharing it.
I shared it, Hema.
Okay.
Henrik, are you able to see it now?
No, still not, nothing.
Yeah,
Now I can.
Now it is up.
Yeah, it's up now.
Okay. So to continue where Hema has hand over, right? She gave the context of what is performance modeling and how the performance modeling can be done with the help of machine learning, right? So to give the context of how it is applicable in the IT systems, basis the various basis various conditions and contexts, right? So in the IT system context, the performance modeling is nothing but you would like to predict the performance characteristics or quality of service characteristics such as response time, throughput, and server utilizations. And this is required to be done for various conditions, like there'll be an increase in the user load or a transaction load, or there are more number of hardware instances which need to be added up to the configurations. It could be because of multiple reasons. It could be because there could be a rollout, production rollout for a new country or a new user base around the corner, or there is a merger and acquisition which might have taken up, because of which you are anticipating more number of concurrent users or concurrent transactions coming into the system, which really requires the IT managers and the infra managers as well to ensure how you are well ahead to identify the areas and the layers in your complex technology landscapes, and then see where you can take the action quickly and proactively, right? So that's where performance modeling techniques will really help. The key areas where it will help is it will help in terms of making a data-driven decision making, right, rather than just going with some gut feel, right? The data is the key to make certain decisions, so that will help in terms of procuring the required additional hardware for the future workloads, and also it helps in terms of identifying the specific metrics, because with the advent of distributed technologies and new technologies and cloud, especially where the cloud plays one of the major roles with respect to the deployments, right? So you have so many instances, so many application processes running, and all these underlying processes generate so much of data. So how do we ensure that we make use of this particular data effectively, rather than manually? You can make use of the techniques of machine learning to ensure that the hardware utilizations are well tracked, and from that data you can create certain models and then try to come up with predictive performance algorithms or performance models that will be helpful in terms of not only procuring your hardware, but also identifying some of the layers and then tune or optimize those specific layers. So all this particular exercise will help reduce the overall cost and time. And then sometimes you don't need to really carry out these multiple trial and error performance runs. If you have this particular data and these models created, it will help you point to the right aspects of your technology landscape, and then it will help you avoid these multiple trial and error runs as well. So having said that, the idea here is to showcase some of the various performance prediction techniques, right? As I mentioned in this particular slide, if you put across, in the cost and accuracy spectrum, there are multiple ways and means a performance modeling exercise can be done. It can be based on certain thumb rules. It can be based on certain linear projections, or it is based on analytical models, which are predominantly based on certain mathematical formulae, right? Or it can also be implemented with the help of the proven techniques of queuing network models, which is basis on the sound principles of software performance engineering, and with the advent of a lot of processing power available, right, and infra becoming much cheaper to in terms of calculations and other things, right? So we can make use of the machine learning as well, because some of these algorithms have been there since ages, but it is just that the applicability of these algorithms to the amount of data is getting more relevant in the current context, in the current digital world, where you have a lot of new technologies and the underlying processing capacity is also increased. So that's where the machine learning comes into picture, and then it will help in terms of predicting the data from the test data which is being given as the insight. So besides that, we have a couple of other techniques like simulation techniques and real environments, as Hema rightly mentioned. In certain business scenarios, it makes sense to go for the real environment as close to, creating a test environment as close to the production environment. But in most of the scenarios, there'll be certain constraints and challenges with respect to the cost and the lead times available. So that's one of the reasons where we need to identify the specific methodologies that are falling in the middle of the cost and accuracy spectrum, so that you take the best of both worlds, right? You don't have to invest too much of cost, as well as at the same time you don't forego with respect to the accuracies that are being predicted out of the data. So that's where the analytical models fall into the picture, and which is being supported with respect to the machine learning. So the key considerations with respect to the performance modeling using machine learning or any other techniques is one has to understand that it is not a complete replacement for activities like performance baseline or benchmarking, performance tuning or optimization. Rather, these techniques will help complement some of the other performance engineering activities like code profiling, bottleneck identification, and deep dive analysis. So that way, you will be the practices that are being followed for your clients or for the organizations where you deal with, they'll become more mature. And the second point, as Hema already mentioned, more the data, more accurate. So especially with respect to the machine learning algorithms, if you have less amount of data, the algorithms will take time for a period of time. The algorithms will take time to train the models. So it is better to have bigger and larger data sets, and that's where you try to minimize the granularity of the sampling that can be captured from the underlying production or QA systems, and then try to take the data, create models, which I'll be showing in the next couple of slides. So having said that, the approach to implement machine learning in the context of performance modeling is a three-phase or a three-pronged approach. The first one is to identify the key prediction use cases, which are relevant from the business context, right? So as I earlier mentioned, it can be a merger or acquisition, or a new rollout, or it can be migrating from the old systems to the new systems, right? And thereby you have a business requirement at hand to understand what are the loads which I'm supposed to handle and how I should be prepared well in advance, so that I'll be able to, IT managers or IT owners will be able to handle those situations without having any surprises in the production systems. So to broadly categorize that, it'll be one is to predict the capacity usage with respect to the utilizations of the systems. It could be the resource utilization or the CPU utilization, CPU memory, JVM heap usage, or the JDBC connections, or the number of sessions in the JVMs which are active at a given point in time. So all of these aspects at the application software layers the software layers will utilize underlying hardware capacity as well, right? So those are the metrics which need to be analyzed and captured from QA and prod. The second business case is, we are more interested in, okay, fine, I'm able to get the required hardware for the given or anticipated workloads, but what about the response? The actual performance QoS attributes like the response time and throughput. How will it vary, or how will it behave with the increase in user load or a transaction load? So these are the broadly two categorized business use cases which can fit for any specific business requirement, especially from a performance prediction perspective. So for these two business cases, the key the key data points or the key metrics which need to be captured are with respect to the resource utilizations and the response time and throughput. So this can be captured with the help of multiple monitoring systems, or it can be used with the help of APM suites like Dynatrace or New Relic or AppDynamics, or it can be complemented with certain customizable shell scripting and Python scripting based programs, which can also capture the data. So all this data can be utilized to use, these data can be given as the input for some of the models using the machine learning algorithms like the logistic regression or neural networks or support vector machines. And especially in this particular scenario, with the help of these characteristics or attributes, you're trying to predict these metrics, right? These end goals of your business requirements. So for this particular thing, from the machine learning algorithms, all the supervised machine learning algorithm techniques like logistic regression or neural networks or support vector machine will help. How we have to identify which algorithm is more suitable is something which I'll be showing in a demo quickly, and what are the various aspects of it which need to be looked at from the performance engineers or performance architects perspective. As I mentioned, it falls some of these techniques that help to predict the resource utilizations and response times. They will be falling under the supervised machine ML algorithms. We have unsupervised as well. That is something where it can be used for log analysis, or over a period of time you want the systems to learn on its own. So that is something, another piece of it which we are exploring as well. But for the context of this particular conference, the demo, what we are going to show is with respect to attributes of CPU utilization, disk busy, memory utilization, active threads, run queues, or active processes, based on which we have created the models using some of the regressions, machine learning algorithms. And then once you generate these once you create these models using the algorithms, what is the basis to validate how accurate the systems are, how accurate these models are, right? So there are some of the key things from the machine learning algorithms that can be looked at. The key things are with respect to the root mean square error or mean square prediction error. So the smaller the number, it indicates that it is a greater accuracy. So there is a way to compare and contrast between these different algorithms and then identify which is a better algorithm for the given data. So remember that not for all data points and for not all the systems, we can there is no single rule or formula or guideline which says that, okay, fine, if for this particular thing you can go and use only neural networks, or you can go and use only logistic regression, or you can use only SVM kind of algorithms. So it is again it is a research activity where you take the data, look at the specific characteristics, and then try to identify what are the specific attributes basis which you can identify and finalize on the accuracy with respect to what it is compared to the actual values. So having said that, this particular this is what I was just referring in the previous slide, right? As part of the overall solution approach, what I just talked in the previous slide, the key to do that is take the data and then give that as a trained data, and you create these machine learning based performance models using various algorithms. And this test data is where you will define what is your end goal, like whether it is utilization or response times or throughputs, basis which you'll be able to look at the prediction results. So having said that, let me just quickly share my screen where this is being implemented using a Python based machine learning algorithms. So let me just open this particular thing. So in the interest of time, what I've done is I have kept the model open, wherein we have taken a set of data from one of the live Windows servers over a period of 1 week to 10 days. And then we have captured the various performance metrics like the processor time, the average disk queue length, current disk queue length, the total thread count, and the total memory available. And here what we've done is we have made the percentage disk time as a target variable. So the idea is I want this particular data. These are the various attributes of the data which are captured, and I'll also quickly show you, give you a sneak peek of what is the data that we have captured. If you look at this particular window, this shows around 3,800 instances of data with 6 different features, right? And here, what we've done is we have made the disk time percentage of disk time, which is nothing but the percentage of disk usage over a period of time, right? So we want to ensure that how this data can be predicted, how this particular values can be predicted with the help of all these other attributes which are interrelated among themselves. Right, so that is where the machine learning algorithms will play a major role. It can be 3,800 today, and tomorrow it can be around 38,000 or 380,000 as well. Right, so all I need is just update the specific file, and then it will make use of this data. So as part of, so this is my train data. So what I've done is using this, I have defined what are my attributes which are the target variables. The target variable indicates which need to be predicted basis for the given business context, which I mentioned in the previous slides. And these are the various features or characteristics based on which I'll be interested to identify this target variable. So the more the data, the more other characteristics like you can include the number of disks available, the disk spindles available at a given point in time. You can use all of them as the features, and then which can in turn define your overall percentage of disk utilization for a given system. So that is the beauty where it is a extendable and robust model where you can keep on adding it, and then you don't need to make any other changes except that you get the required amount of data, and then give it as an input. On the other side, right, this is the test data, right? So here as well, I just follow the same features because I want to ensure that the train data and the test data are the same with respect to the characteristics and the target variables. And so here, just for your understanding, what I do is I make the percentage of disk time as a target variable without having any details, right? So over a period of time. So as part of this particular demo, the idea is to showcase how these algorithms will be helpful and how predictions how the accuracies are with respect to the predictions between the actual data and test data. So for that reason, what I did was I created a specific characteristic, which is the target variable. At the same time, I've kept the actual disk time actual value as well. So the idea is to just give a quick comparison between these two values once the model is done. So with this particular data, we have created multiple algorithms using linear regression, neural networks, and SVM. And there are these predictions which will be taking an input from. It will take the input as one of the models and the test data and the train data as well. If you see this, it takes the input from the one of the models and the test data as well as the train data as well. So in the interest of time, what I did, I just ran this particular things before. So if you see here, it shows the predictions, right? The predictions show. So this is the target variable, and the linear regression says that, okay, this is the predicted values using the linear regression algorithm versus this is the percentage of disk time actual. If you see here, the values are very close, and I'll just show the other screen where we have even evaluated across the various machine learning algorithms for the same data for different algorithms. So that way I'll be able to show that as well. So the point here is these algorithms are very helpful. Ensure that they'll be able to provide the right levels of prediction accuracies. And if you see here, I can just scroll down for the entire thing, and wherever you see, now you will be able to see the data very close, even to the fourth decimals, right? So that is the kind of accuracies that we are able to get by running these algorithms. Similarly, I'll just show you for the neural networks. So in this scenario, for the neural networks, we have seen that it is not really matching with the kind of data what we have got here. So probably it could be because this particular model is not, this particular algorithm might not be as suitable compared to the linear regression for this particular data. But again, as I said, it has to be tried out with multiple algorithms, and then we need to look at the final scoring of all these algorithms. So this is what is being done by using this particular widget, what it will help is it will help to create what are the evaluations for the specific data sets and for the given data sets for the specific algorithms. So if you look here, right, this is what I was just referring to, the root mean square errors, right? So the lesser the value, it gives a clear indication that the linear regression is more suitable for this particular thing, and the R2, right, that gives it is closer to 1. It represents that it is the most choice. I mean, it is the most suitable for the given data set at hand. So whereas SVM it's going too away from the results are going, the actual predictions are going much away from the actual results. So that's where we see the negative values as well, right? So I'll just show the details of the SVM as well. So here you can see that it is going, even to away from the results, the actual values. Okay, so these are the actual disk time, and then this is the predicted disk times. So this is not really matching with. So for this particular data set, we find that this is a right linear regression. The best part of this is, right, as we have this limited amount of data as of now, from the production, we can keep live feeds for this particular source, right? And then your test data is nothing but the various scenarios where you want to have the anticipated percentage of disk times, or whatever it is. It can be processor time, or it could be disk queue length, or it can be the total number of threads at any given point in time. We can define whatever is the required metric which need to be predicted, and then accordingly choose the other attributes which will have direct or indirect correlation, and then do a compare and contrast with respect to the outcomes of the predictions. That is what is summarized in this particular slide. And as an extension to that, right, some of these ML algorithms will also help in terms of doing anomaly detection and the outliers as well, right? So for this particular data, what I try to do is try to get a correlation between the percentage of processor time and the percentage number of active threads at a given point in time, right? So this indicates that this kind of gives a quick view, right, rather than looking at the entire data and then trying to dig through each data points in the spreadsheet, right? And imagine that if you have a 100K or a 200K amount of data from a production system for a 2 weeks time, and then you need to quickly deep dive into the specific context and the times at which it is having an issue. These kind of analysis from the using ML will also help identify, hey guys, you look at this. For this particular scenario, we are seeing around a few instances where it is touching your CPU going to 100%, right? And that has a direct correlation with respect to your process thread count going 3000. Yeah, and then we can look at these specific points and those specific instances, how we can go and correlate it back to the business process which are running at that point in time, and then see how we can deep dive, and then dig into the root cause with the help of the APM suites or any profiling tools available, or any kind of custom logging enabled in the systems, which will help to identify the root cause at the code level or configuration level. So those are some of the extended benefits with the help of using ML algorithms for huge amounts of data sets. And of course, we are still in further works with respect to how we can utilize the unsupervised learning or supervised learning techniques with respect to the log analysis and stuff like that. So I think with that, we have come to the end of our presentation and the demo as well. So if you have any specific questions, I'll be happy to take them further.
All right. Awesome. Thanks, Emma. Thanks, Madhu. There were questions that have been asked, and I noted some questions as well. So let me go through those questions. In fact, one of the questions that I had was also asked by one of the attendees. In fact, one of the attendees is one of our speaker of the previous pack. So I'm going to try to interact him lively.
Madhu, if you stop sharing that,
I'm going to ask the question. So the question that I had is, what was the tool that you used? Someone in the attendees answered says Google Colab. Can you confirm?
Okay, the tool that we have used is it's an open source tool which is based on Python, which it is Orange.
Orange, like
it's
like
Orange.
the telco company, like the telco company.
Yeah.
Orange.
Yeah. It's a database. It's a data model, data analytics or data specific analysis based organization, which created a simple and easy to use widgets. All these widgets will run based on, for example, they're all based on Python scripting. And even if you want, we can create certain Python scripts on top of the data and then do further data transformation, data massaging, and so on and so forth as well.
Okay, cool.
So the underlying uses Python.
Yeah, because I saw that you're able to configure the workflow of the data and where you want to place the scripts. I thought it was a pretty interesting tool, and I think that Jonathan made that questions. Jonathan is configuring the webcam. Hi, Jonathan. How are you? Do you hear us, Jonathan? Okay, never mind. So one of the question I had, especially related to predictive or based on machine learning to compare some behavior that you have measured in production and something that you're measuring in testing environments. So you took the example of a disk. So I guess one of the biggest requirements is to make sure that a structure that you are going to have in your testing environment is exactly the same that you have in production environments in order to predict the behavior. Because I guess if you have a server that is nothing related in production and in your testing environment using I don't know, containers or whatever, you won't be able, the model or the machine learning won't be able to provide much results out of that. So my question is, I guess one of the requirements is to have a testing environment that are aligned with your production.
Yes, Henrik. Are you hearing me?
Yeah, I can hear you very well.
Yes, that's right.
Yeah, so
and other thing is you showed us you took example of two different machine learning algorithms. There is plenty of different algorithms. So you highlighted two models. Is there any other algorithm that is worth to explore? Do you have any recommendation for our community about it?
yeah, so for the kind of predictions that are required, right, with respect to the deterministic attributes of the data, right? Yeah, we can make use of logistic regressions or neural networks or support vector machine, and there are a couple of other algorithms as well, like you have a stochastic gradient event as well, right, SG. But again, some of these algorithms, we need to validate for each one of them because, as I mentioned earlier, there's no one algorithm which we can say that okay, fine, for this particular thing only this can be used. It is rather it's an exploratory way of picking up these algorithms and then see how they are able to predict and what are the prediction results and what are the, because at the end of it, all these algorithms, what they do is they try to fit into a specific a mathematical model underlying with certain coefficients and error accuracies to give a correlation between your predictor variables versus the dependent variables, right? So there are a couple of multiple other algorithms as well, right? The stochastic gradient and there are other vectors. Whereas if you are looking at log analysis and trying to classify, right? Because this typically falls under the regression. Whereas for the classifier algorithms, you have many more, like the B-tree algorithms and a couple of other algorithms as well. But that again is something where if you the business use case will be like you can take that and you can take those algorithms to try and see how you can categorize the kind of error, the kind of analysis based on the logs. So that requires, I mean, that's where other algorithms like classifier algorithms will be really helpful.
Thanks, Madhu. There is one question from the attendees, and then I will ask the other PAC members connected. So Jonathan had a question, so I will ask Jonathan, and then Harry, and Yorek is connected, so I will take advantage of also having Yorek connected. So the question is from Joey Hendricks, and the question is, how do you validate that your training data is still relevant after changes that happen in the application that you are testing?
Right. So typically for that, right, Henrik, what can be done is whatever is the test data that is being considered, and as I shown, you have two pieces of two major components in the entire machine learning based models. You have the test data and the train data, right? So once specific changes are being made, right, the basis for that, again, you need to create a fresh test data. And fresh train data after the issues are fixed. For example, let us say you have a disk issue and the underlying disk is addressed, or you have added additional disk specific disk related resources to the system, right? So for that, what need to be done is you take the new baseline and then use that as a train data. And then as you use your system over a period of time, you make that as your some of your test data, you can also try to put it back to the train data so that your train data becomes more robust and it will be able to predict for the future anticipated workloads or future anticipated requirements.
Thanks. Joey, I hope that Madhu has answered your questions. Let us know through the chat or from the Q&A if it's fine. Harry? Harry, do you hear me?
Yeah, sure. So some other quick question. Is it audible? Yeah.
Yeah, you're audible.
Okay, so you spoke about taking the production data which had some of these components, right? There's memory and other items. But when you look into production, the user load also varies constantly, right? So how do you, now it's more like a one-dimensional thing where we looked into the resource utilization and then predicted it. But the key input would be the user load, and it keeps varying, right? You run bad jobs, you have high volumes at one point in the day, and then it keeps changing based on a daily basis. So how do you also factor that in your model and then start predicting some of these metrics?
Right. So for that, so for that, Harry, we have used one of the specific attributes which will be directly impacted with respect to the number of concurrent users, or number of concurrent processes or applications which are running in any given system, which is nothing but your number of active processes or active threads, right? So that's one of the data attributes which we have collected. Probably I can just quickly share that too, right? So that's one of the key attributes that we have used while to be trying to predict what exactly is happening, because that is in my view, that's one of the key things which will tell you what exactly is happening with respect to the number of processes or number of thread count at any given point in time. So depending on the type of application that you are referring, whether you are talking about a simple process-based application, or if you have a multi-thread environment like a Java JT system or a microservices environment, right? You need to consider that as one of the key characteristics which will define or which will directly influence any of the utilizations. underlying utilizations. So that is one of the key characteristics which is considered as part of the entire data that is being given as a test data.
Okay, got it. Thanks.
Jonathan, do you hear us? Do you have any questions to the topic presented by Madhu and Hema?
Yeah, so I'm just, can you hear me okay?
Yeah, we can hear you very well.
Perfect. So I'm just loading Orange on at the moment. And so I'm using Grafana and to monitor a whole stack of pods that are doing on an AI platform. And I was just kind of wondering, as far as things like OData, and you said about just any logging you can hook into it. Have you had any experience with tools like Grafana and what you're looking at for predictions?
You're referring to the Grafana dashboards like Grafana, Jonathan?
Yeah, Henry, can I share my screen, or just to give an idea of what I'm looking at?
Yeah, you can share a screen. Yeah, normally you have the rights to share a screen, right?
Whereabouts is it?
Normally you have a share option, and you have a share option button on the right side of the web extension, and you can share a screen or share videos.
I've got moderated chat. I don't have a share screen button though.
Because you're connected as an attendee, and so you have the attendee screen, so that's why that's why. No, I'm sorry, you're not able to share a screen. I'm sorry.
No problem.
What's the name of the tool you were referring?
No worries, Jonathan. I think if you're referring to how to get the data or how we can utilize data coming from Grafana dashboards and then how we can integrate with ML algorithms, is that your question? Did I get it right?
Yeah, that's my question.
Absolutely.
Around OData format is, similar to Dynatrace. If I was going to take the data out of Dynatrace, how best would you go about doing it?
All right. So the way to deal with that is, Jonathan, in my view, is we can get data from any source, whether it can be a simple spreadsheet or a CSV file, or it is coming from a Grafana dashboard, or if it is coming from an APM suite like Dynatrace or New Relic. What needs to be done is, we can, as I mentioned, right, you can create a simple Python-based scripts which can read the data and then do some data transformation on top of it, and then provide that as an input to the algorithms. So for me, it is like, you can create an abstraction on top of, just in front of your models, which I've shown. For the sake of the demo, I have taken a simple CSV file, which I have picked up from one of the Neotys monitoring tools. And however, if you want to integrate with any of the specific monitoring tools in production, the simple way to do that is write a shell script or a Python-based script, and then try to connect that give the output of that as an input for the performance models.
Excellent. No, that's a really good answer. Thanks.
Thank you.
Thane, I see that you're connected. Do you have any questions to Emma or Madhu? Thane, you're muted. You're on mute. Oh, I don't hear you, Thane. Thane, you're probably have mute your mic because we don't hear you. No. So unfortunately, there won't be any questions from Thane. Or you can drop your questions. I don't know why, but I don't hear your mic, Thane. So you went wrong. So good questions by Jonathan. So I'm gonna drop. So it's not related to the presentation that we had happened. It's the Slack channel. So there is a Slack channel. By the way, it's called. I'm gonna drop it. So in the chat. So it's Neotys pack slack.com. So you can reach out to us, and if you want to interact, of course you can join us and we can chat. But obviously the chat of Bluetooth is working perfectly well. All right, so it's left before the next presentation that will be presented by Uma and Harry from Cognizant about SAP performance testing. So I would like to thank Emma and Madhu for your presentation. I think it was a really interesting topic and showed the insights, and the demo I think was pretty interesting and give us a pretty well understanding on the approach and how we could leverage machine learning to at least figure out if there's any regressions compared to the production. But I think you made it the last topic saying to figure out bottlenecks. I think that's area I think could be super efficient to take advantage of machine learning. All right, thanks Emma, thanks Madhu. So I will take a short break just to fill in some coffee. So I forgot to count my coffee levels. So I think I reached out about 10 coffee now, and there will be more to the end of the day. So let's connect in. So it's 11 to